Hello and welcome to another episode of AWS Cloud Bytes Architecture series. I'm your host Bhavesh Kumar. Friends, if you like these videos, please subscribe and click the notification bell icon for future updates. Also comment on topics you want me to cover. Today we are going to talk about a high-level design consideration for a well-architected framework. AWS Well-Architected Framework. The AWS Well-Architected Framework describes the key concepts, design principles, and architectural best practices for designing and running workloads in the cloud. The AWS Well-Architected Framework provides architectural best practices across 5 pillars for designing reliable, secure, efficient, and cost-effective systems in the cloud. We are going to deep dive on these 5 pillars. And the framework provides a set of questions that allows you to review your existing and proposed architecture. AWS Well-Architected Framework provides you a guideline to build things in the cloud, how to host things in the cloud, what are the benefits of doing it in the AWS specific cloud way. The 5 pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. We are going to deep dive in each one of them. Let's go to the first one. Operational excellence. Perform operations as code. In the cloud, you can apply the same engineering discipline that you can use for application code for your entire environment. You can define your entire workload, whether it is application, infrastructure, or anything apart from that, as code and update it as a code. You can script your operational procedures and automate their execution by triggering them in response of an event or events. By performing operation as code, you can limit the human errors and enable consistent responses to events. Make frequent, small, reversible changes. Design your workloads to allow components to be updated regularly to increase the flow of beneficial changes into your workload. Make changes in small increments that can be reversed if they fail to aid in the identification and resolution of issues introduced in your environment without affecting customer when possible. Refine operations procedures frequently. As you use operations procedure, look for opportunities to improve them. As you evolve your workload, evolve your procedures appropriately. Set up regular game days to review and validate that all procedures are effective and that the teams are familiar with them. Anticipate failure. Failure is inevitable. Perform a pre-mortem, not the post-mortem. Perform pre-mortem exercises to identify potential sources of failure so that they can be removed or mitigated. Look for single point of failures. If your application is multi-region, test your failure scenarios. Validate your understanding and their impact. Test your response procedures to ensure that they are effective and that teams are familiar with their execution. Set up regular game days to test workloads and team responses to some kind of simulated event. Learn from all operational failures. Drive improvement through lessons learned by operational failures. All the events and failures that happened, learn from them. Share what is learned across your team and update your playbooks. Also, look for failures in different organizations and see if they actually apply to your organization also, and see if you are able to work through those kind of failures. The next pillar over here is security. Let's talk about security. This is one of the most important pillars. The first point here is implement a strong identity foundation. Implement the principle of least privileges. Don't give full admin access when you just need read-only access to an S3. Enhance separation of duties with appropriate authorization for each interaction with your AWS resources. Centralize identity management and aim to eliminate reliance on long-term static credentials. Don't go by storing credentials. Don't share credentials. Enable traceability. If something has happened, which will happen? So how can you monitor that? Do you have good monitoring, alert, audit mechanism? Look for monitoring, alert, audit actions, changes to environment in real time. Integrate log and metric collections with systems to automatically investigate and take actions. Apply security at all layers, or you can say defense in depth. Apply a defense in depth approach with multiple security controls. Apply it to all layers, for example, at the edge of the network, VPC, load balancers, every instance, compute services, operating systems, application, and code. Just put security measures in every layer. Wherever possible, apply security. Automate security best practices. Automated security or software-based security mechanism improve the ability to securely scale more rapidly and cost-effectively. Create secure architecture, including the implementation of controls that are defined and managed as code in version control templates. Protect data in transit and at rest. Classify your data based on the sensitivity level and use mechanisms such as encryption, tokenization, and access control wherever applicable. Keep people away from data. Use mechanism and tool to reduce or eliminate the need for direct access or manual processing of data. This reduces the risk of mishandling or modification or human error or any kind of leak of data when handling some kind of sensitive information such as PII information, HIPAA-related health information that is being shared. Build an abstraction for anyone who is using data. Provide people a view of data. Don't give the access to overall data. Prepare for security events. As in the previous slide, we talked about operational preparedness for any kind of security threat. Any kind of incident management or investigation that you need to run. Prepare for that. For incident management investigation, you have to have a policy in place and a process in place that aligns to your organizational requirements. Run an incident response simulation and then use tools with automation to increase the speed of detection, investigation, and recovery. Moving on to the third pillar, which is reliability. Automatically recover from failure. A reliable system should be able to work around failures. By monitoring a workload by its key performance indicators or KPIs, you can say, you can trigger automation when a threshold is breached, such as if you need a scaling because the workload is too high, you may have another compute instance available to scale the workload or distribute the workload. These KPIs should measure the business value, not the technical aspect, and they should be focused upon how we are delivering a business. This allows you to automatically get a notification or tracking by failure, and using the automatic recovery process that works around and repairs the failure, you can have a very sophisticated automation in place. It is possible to anticipate and remediate most of the failures before they occur. Test recovery procedures. In an on-premise environment, testing is often done or conducted by workload in a particular scenario. Testing is not typically used to validate recovery strategies. In the cloud, you can test how your failures will happen, how your workload will fail, and you can validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to failures before. This approach exposes failure paths, and then you can test and fix basically before having a real failure in your scenario, and thus reducing the risk. Netflix uses something called Chaos Monkey that goes into the production. When executed in production, it will just terminate some of the instances that they are running. Some compute instances will be disrupted. Some kind of network failure will be applied. And they look into real-time production environment saying, okay, there is a failure and how we are actually recovering from that. Scale horizontally to increase aggregate workload availability. Replace one large resource with multiple small resources to reduce the impact of a single failure to the overall workload. Distributed requests across multiple smaller resources are much more reliable than a single big EC2 instance running all of your queries. One of the biggest advantages of having cloud is that you don't have to guess the capacity. Stop guessing capacity is the next point here. A common cause of failure in on-prem workload is resource saturation. When the demand placed on a workload exceeds the capacity of the workload, you are not able to serve a given capacity just because you are very rigid about the max capacity in the on-prem environment. In the cloud, you can monitor the demand and workload utilization. And on top of it, because you know the demand, because you can monitor the demand and workload, you can automate it by adding or removing resources just to maintain an optimal level of satisfied demand without over or under provisioning. There are still limits, but some quotas can be monitored, controlled, and others can be managed. Manage change in automation. Changes to your infrastructure should be made using automation. The changes that need to be managed, including changes to the automation, which then can be tracked and reviewed. So any kind of change that you're doing should be auditable, can be tracked back to the change that has happened. You should have versions around it. Moving on to the next pillar, which is performance efficiency. The first point here is democratize advanced technologies. Making advanced technologies implementation easier for your team by delegating complex tasks to your cloud vendor. Rather than asking your IT team to learn about hosting and running a new technology, consider consuming technology as a service. An example of it will be a NoSQL database, media transcoding, and machine learning. All these are technologies that require specialized expertise. In the cloud, these technologies are available as services, and your team can consume those services. Allow your team to focus on product development rather than resource provisioning and management and deep diving into a core technology that is already provided as a service. Go global in minutes. This is core of any cloud technology or cloud provider. Deploying your workload in multiple AWS regions around the world allows you to provide lower latency and better experience for your customers at a minimal cost. If you're running workloads in US East 1 and then you have a lot of traffic coming from Europe, US East 1 will have a big latency if you don't have a presence in Europe. So it's better you can roll out same services in Europe so that you can serve your customer with lower latency. Also, you have to design your application in a way that your application is serverless and your databases are available in a way that it can serve multiple regions, and there is low latency between database sync also. You can choose databases such as Aurora, which is multi-master and has a bidirectional sync. Use serverless architecture. Serverless architecture removes the need for you to run and maintain physical servers for traditional compute activities. An example of it will be serverless storage service can act as a static website, and event services can host code. This removes the operational burden of managing physical servers and can lower transactional costs because managed services operate at cloud scale. You can use serverless frameworks. You can run code as a Lambda service, which doesn't need allocation of any kind of physical server. Lambda runs in a container, which runs on some hardware allocated by or maintained by AWS. So it's not that it is truly serverless in the sense that it doesn't need a server. There is always a server. So you don't have to allocate or get an EC2 instance to run your Lambda. When you invoke a Lambda, it's one of the cheapest options available because you are billed by the amount of memory and the time you're executing and the number of instances Lambda have executed. And under the free tier, you have more than 1 million, I believe, Lambda executions. Experiment more often. With virtual and automated resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. Consider mechanical sympathy. Use a technology approach that aligns best with your goals. For example, consider data access patterns when you select database or storage approaches. Moving on to the last pillar, which is cost optimization. Implement cloud financial management. To achieve financial success and accelerate business value realization in the cloud, you must invest in cloud financial management. Your organization must dedicate the necessary time and resource for building capability in the new domain of technology and usage management. Similar to your security or operations capability, you need to build capability through knowledge building, programs, resources, and processes to help you become a cost-effective organization. Adopt a consumption model. Pay only for the computing resources you consume and increase or decrease usage depending upon your business requirement. For example, development and test environments are typically used for 8 hours a day during a work week. You can stop them when they're not used and over the weekend, which can give you a potential saving of like 70-75%. Measure overall efficiency. Measure the business output of the workload and the cost associated with delivery. Use this data to understand the gains you will make from increasing output, increasing functionality, and reducing cost. Stop spending money on undifferentiated heavy lifting. AWS does the heavy lifting of data center operations, such as racking, stacking, and powering servers. It also removes the operational burden of managing operating systems and applications with managed services. This allows you to focus on your customers and business projects rather than IT infrastructure. Analyze and attribute expenditure. The cloud makes it easier to accurately identify the cost and the usage of workloads, which then allows transparent attribution of IT costs to revenue streams and individual workload owners. This helps measure return on investment and gives workload owners an opportunity to optimize their resources and reduce costs. Today we covered 5 pillars of AWS Well-Architected Framework. If you want to use AWS in the most fruitful manner, you should deep dive on these pillars. You should verify if your AWS cloud infrastructure is running and adhering to cloud best practices or not. Suggest corrective actions and measures to your teams and get appreciation for helping in building a better cloud journey for your companies. Thank you for watching. As usual, if you like the video, please like, subscribe, and press the notification bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.